Thank you so much for taking time out to join us for the IRIS webinar on physics and astronomy. I see a lot of people who have joined today, and we are so very happy to have all of you here with us. We can see a number of teachers and a number of students and a number of people from other organizations as well. Very welcome to all of you. So before we begin, let's take you through a very brief PPT on IRIS. So IRIS, as you know, is the Initiative for Research and Innovation and STEM. It's a great platform. It provides you with an opportunity to get recognized on the world stage, and it inspires research and innovation in the field of science. IRIS guides and mentors you to improve your research-based project. So we have an initial round wherein students are asked to submit their synopsis online. After that initial round, all synopses go through a process of evaluation by our esteemed scientific review committee. And on the basis of synopsis, students are selected to be invited for participation in the IRIS National Fair. Once you participate in the IRIS National Fair, you are then judged again. The projects are judged again. And students in the senior category are given an opportunity to participate in the International Science and Engineering Fair, the Regeneron International Science and Engineering Fair. Students in the junior category get the opportunity to win a chance to participate in the Broadcom Masters program. So the key objectives of IRIS, of course, we hope to stimulate young minds to take an active interest in science and technology. And the webinars that we are hosting and we are having as per the 21 subject categories are witness to this. We also encourage students to use research as a tool for creating new knowledge. I'm sure all of you will agree that this is the opportune time for people to be actually researching online, if not offline, for a lot of things, and to come up with new projects, to research ideas that they have, and to give shape to projects which can later be a boon to society. Can I have the next slide? Yeah, so the annual IRIS timeline, according to that, this is the time when we should be having face-to-face webinar, face-to-face workshops. But since that is not happening, we thought let's go ahead and do webinars. And so this is the 10th webinar in the series. Recordings of the previous webinar are available on the irisnationalfair.org. It's the IRIS website, and it's also available on YouTube. So we hope to be able to open the platform for synopsis by end of July or beginning of August. And let's see, if everything goes well, we should be able to let you know when we can have the IRIS fair. We still don't know whether it's going to be virtual or face-to-face, but just like everybody else, we are taking one day at a time. Next slide, please. Yeah, so the participation eligibility is that we allow students, or we welcome students of Indian origin from schools based in India to participate in the IRIS National Fair. If you're a student who is studying in a school in India but is not a citizen of India, then we are very sorry. We will not be able to allow you to participate in the IRIS National Fair. Students can participate individually or in a team of 2 students. The junior category from 5 to 8 qualifies for the Broadcom Award. The senior category, classes 9 to 12, competes for participation at ISEF. Students who have completed their class 12 board exam at the time of project submission will not be permitted to participate. So the reason that we are very categorically calling this out is because we have in the past had people who have completed their class 12 board exams and then have said that they are taking a gap year and so have wished to participate, but we are very sorry. once you have completed your class 12 board exams, even if you're taking a gap year before your, before enrolling for your undergraduate studies, we are sorry, but we will not be able to permit you to participate in the IRIS National Fair. If you're studying in class 9, 10, 11, 12, welcome. You can participate as a student in the senior category. Um, you can associate with IRIS, however, other than as participant, as a volunteer, as a mentor, and to collaborate with IRIS. So volunteering would be for a number of things like the camps that we hold, whether online or offline, for the national fair. The mentoring is, of course, to ensure that students who are participating are guided well, and you can be a mentor for those students. You can collaborate with IRIS by offering your lab facilities or your campus facilities for students during the camps and during research for projects, and we will be very grateful to you for that. We welcome our two esteemed speakers today. Dr. A. Srinivasan. Professor Srinivasan is the Dean of Faculty Affairs, IIT Guwahati. He's a member of the IRIS Scientific Review Committee. In fact, he has been with the IRIS program right since its inception way back in 1999. His current research interests are in applied materials and instrumentation. He has published 143 papers in peer-reviewed journals and supervised many PhD student thesis reviews and works. Dr. Srinivasan is a recipient of the Department of Atomic Energy Young Scientist Research Award in 1996. Thank you so much, Dr. Srinivasan, for joining us today. We also have with us Dr. Vijay Kumar. Dr. Vijay Kumar is presently working as Assistant Professor, Department of Physics, National Institute of Technology, Srinagar. He's a member of the IRIS Scientific Review Committee. He has received the Young Scientist Award under the Fast Track Scheme of the Department of Science and Technology, Government of India. He is currently engaged in the research of functional materials, ion beam analysis, solid state luminescent materials, biodegradable composites, smart polymers, and biomedical applications. Very warm welcome to you too, Dr. Vijay Kumar. Both our experts will be taking sessions with you on physics and astronomy. And participants, just a gentle reminder, please keep your questions till after the speakers finish with their presentations. You may, of course, type your questions into the chat box, and we will call them out when the speakers have finished with their presentations. So without further ado, I welcome Dr. Srinivasan to take over and start with the presentation for the day. Thank you so much.
Thank you, Sharon. Yeah. Can you see my slides? Hello?
Yes, sir. It's not
Hello?
visible yet, sir.
Not yet, sir. Not yet.
Hope you are able to see my video, my slides. Hello?
No, not at present.
Hello?
Yes, sir, we can hear you,
Is it
but
clear? Are you able to see me?
see, we can see you, but not the slides.
Hello, is the problem?
Good evening, sir.
Let me first hope you're all safe and healthy, and so are your family members and your classmates. So this is actually a wonderful time. You may feel that this is a very bad time to study, but actually it's a very good time. In fact, you have all the time in the world for you to pursue whatever you want. But the only thing is that you'll have to use online mode rather than offline mode. Okay. In fact, if you know about you all know about Albert Einstein. You know, when he actually brought down this famous mass energy relationship, the only contact he had with the world was a small window. He was just sitting in a drab room with a chair, with a high back chair, looking out, and then he was kind of working out this great idea, which is actually so very wonderful. That one of the best physics derivations they ever had, E equal mc squared, right? This time is not going to be a limitation for you. Okay, in fact, you have a lot of time. So please look in the positive way, and then try to bring out your innovations out and your creativity out, because creativity and innovation cannot be stopped by anything, especially coronavirus, huh? So, or by a confinement. Okay. So now what I want to do here in the next 10-15 minutes is to kind of go through kind of the processes involved in actually preparing yourself for this IRIS in physics and in astronomy projects. How will you go about and prepare a particular project? That's what we are going to discuss now. Okay, so let us move ahead. For example, see, by definition, you know what physics kind of means, because this is actually this definition I have shown here. Basically, they actually come from any site you can Google. Okay, so what is physics? Basically, it's actually it's a subject or a science which is concerned with the nature and properties of matter, energy, and their interactions. Right. So this includes a variety of subjects like mechanics, heat, light, and so on and so forth. I'm sure your physics textbook carries all these chapters. Okay. Similarly, astronomy is a natural science which studies celestial bodies and the phenomena associated with them, right? And it's within these two areas we have a huge amount of topics that come under this. So and there's a lot of scope. So when actually what IRIS does is that to make life much more simple, they actually kind of put the following topics as into what is called the PHYS, that is physics and astronomy category. Okay, so we have what is called atomic, molecular, and optical physics, astronomy and cosmology. So astronomy also now adds up cosmology also into that. Okay, then biological physics, condensed matter physics and materials, mechanics, nuclear and particle physics, theoretical, computational, and quantum physics. So your project that you are going to put up in any of these will automatically come into the physics category. That's what actually I'm trying to tell you. So what actually are these basically? For example, if you really want to expand this, atomic, molecular, and optical physics, it actually encompasses a wide variety of areas, and which talk about the atoms, molecules, the electrons, the light, and their interaction. In fact, you talk about a laser. You might have heard of what is called laser is. For example, a laser comes under the atomic, molecular, and optical physics. And we have very novel phenomena like optical tweezers, by which you can pick up a small nanoparticle with actually by light beams and so on and so forth. All these exotic areas come under this particular topic. The next is, of course, is astronomy and cosmology, where actually we talk about the universe, its origin, its evolution, and the various heavenly bodies that are floating around, which includes, in the space, including our moon and the other planets, and we go beyond the planets to the galaxies and so on and so forth. Okay, so and then comes the biological physics. In fact, that's a very nice area that is coming up. You may know about an area called systems biology coming up very well, where actually we talk about modeling using physical models for various biological processes and systems. So these particular areas come under this biological physics area. Then, of course, the condensed matter physics, which actually includes both solid state physics as well as what is called condensed matter. No, solid state is one part of it. For example, there are certain other materials like fluids, which can become solids and liquids also. So these fluids basically are also come under the condensed matter area, and materials. So these materials areas, there are you know about metals, semiconductors, and there are very interesting properties like superconductivity and and things like that. Even nanomaterials, whether it's 0-dimensional, 1-dimensional, or 2-dimensional materials, they come under this particular category, and also what is called ceramics. In fact, your blood, it is actually in physics term, it is considered to be a complex fluid. Okay, so it's like that. Okay. Similarly, mechanics, of course, you already know what mechanics means because you studied that in your syllabus. and of course then is nuclear and particle physics. This deals with the nucleus and the fundamental particles. You might have heard of the discovery of the Higgs boson recently, and all these come under this particular category of nuclear particle physics, and nowadays we call them high energy physics as well. And then of course the theoretical, computational and quantum physics, which talk about how we can actually mathematically look at the various aspects of physics and the mechanisms. Okay, and of course the theory, quantum theory and other things. Okay, so these are the kind of the areas yours. As you can see that there is a lot of scope to work in these areas. Many things are possible within this. So you can choose any of your projects within any of these subcategories. Okay. So now comes to the big question that everyone asks: how do I look for a problem, or how do I find a project? Where do I get a project idea from? In fact, that's what actually we are looking. We are looking for the bright kids like you who have these ideas running in your head. In fact, many of you do not require for me to tell you how to find a problem, because some of you may already have a problem or a novelty or a new idea that you already is running in your mind. But for those who are still searching, I like to kind of give you some bulleted points. Sorry, my slide is a little bit cramped because I want to push in all my ideas into that. That's what happens when you allow a professor to talk. We always never give a stage to a professor or a politician. They'll never let you do anything else, okay, other than listening to us. So that's what it is. So please bear with the cramped slides. So the first point you have to remember is the innovation and novelty. These are the catchwords in any of the IRIS projects, whether it's physics or otherwise as well. Okay, and then so unless you have these two terms in your idea, I mean, you will lose out. Your project will lose out. Okay, so it has to be innovative and it has to be novel. Okay, and then many people think that, okay, last year we had a project, it was a success, so let me just repeat it or kind of tweak it slightly, little bit. Okay, it was giving a good result. Okay, I'll write kind of infinitesimally improve it by another 2%, 4% better output. Then do you think I can get away with it? You cannot. That's where the whole problem, because such kind of attempts have been found to be not very wise because they are not original. Okay, so the ideas have to be also original and apart from being innovative and novel. Okay, so similarly, an old idea which you are trying to wrap up in a new frame may not sell. Okay, so you have to keep this in mind when you are actually choosing a new project. So what you do is that you merely use the successful projects that we are going to give some examples, or you can look up in the IRIS site, you can find the whole list of them. Okay, as examples are what is expected from a project of your level. Okay, what kind of a project wins an award? Okay, so just to put you in a right perspective, these particular examples are given. Please go through them because they will give you a lot of ideas. Okay, okay. Now, how do you go about then play around with this novelty and this innovation? How do you just look around and see if a particular idea, it can be anything. I'm saying an idea because it can be anything. Okay, or any concept or any device that actually you are actually looking at. Okay, and see whether it is optimally implemented. Okay, and ask these questions to yourselves. First is, can I use my knowledge of physics and apply this particular idea that I'm thinking of in a much better way? That's one way of looking at or searching for a problem. The second thing is, can this physical concept be converted into a working idea or a device that you are actually contemplating? This kind of, can I take this idea forward and make it into a working thing or a device which others have not attempted so far? Or can I prove that this particular concept will work either by theoretical means or by experimental means? There is no limitation. You can also use theoretical means for proving your point as well as an experimental way of doing it. Okay, and then of course, suppose there is a device. Is a device that I'm talking about today, is it the optimal performance that I have, or can I improve it? Okay, if you want to improve it, how do I improve it? The improvement I have to do should be radical in the sense that, see, suppose you have a 1% improvement in an idea, nobody will buy your idea, because 1% increase in a particular performance is not going to induce a manufacturer to throw away all his old infrastructure and try to build new ones for your 1% improved idea. But if it's 10% improvement, and then he will see a big improvement in his sales and other things. He will take your idea and then make the product. Okay, so it has to be kind of a meaningful improvement over the earlier performance. Okay, and then you can also use new strategies. For example, you might have heard some new words like, earlier we used to do a lot of modeling and then things like that. Nowadays you have ideas of what is called machine learning, deep learning. All these ideas are, data mining. Okay, all these are kind of used because now we have the computer power to kind of, brute force you have to kind of try many things that you could not have done maybe 2-3 years back. So these new technologies is coming up, and you can think of whether I can apply this particular technology to an already existing problem or a device, and can I improve it? Okay, and then another way of looking at it is what is the physical basis of a new technology that I'm seeing? Can I kind of look at, apply this kind of idea into another demanding problem and develop that problem so that this particular new technology, this idea which is helping this new technology, can be used to develop other technologies? Or how can I actually get a physical solution for the current problem that I'm facing, or the community is facing, or my country is facing? Okay. For example, this COVID situation has created most of us, believe me, I'm a physicist, and and I have many of my colleagues who are chemists and others and engineers. Almost 30% of my institute is working on COVID-related projects, and we have developed so many things. And in fact, we were also surprised that we could come up with so many innovations within these 3 months, because they say mother is a it forces this demand. I mean, you are forced to actually come up with solutions. See, world wars saw probably the best innovations. Electronics came to the second war. Do you remember this margarine that you are using? It was actually developed by Napoleon army because he could not get butter for his troops. So that was a substitute made from vegetable oil and other things. That's how the margarine came. It came through a war, during wartime. Similarly, your electronics had the best development during Second World War. Okay, so because that time you have to, for sake of survival, you have to come up with new innovations. That's how new ideas come. So you can always find, solutions for even COVID. I'll not be surprised. Okay, but you have to find something which will suit the physics background to put it in physics. Otherwise, you can go into other sciences, biological sciences, and other thing. Okay, then how can I kind of now? And another thing is, suppose you look at a concept and it has failed. Okay, to solve a particular problem. Then you can say, can I put in another idea or another concept and then put it to address this? So you may say that you may think that I'm being very vague. I'm not being vague. I've been deliberately using the word an idea, a concept, a device, because I don't want to push in ideas into you. And that is not the way an innovative project comes. It has to come from you. So you have to kind of, now close your eyes and think, okay, and then what kind of idea that is in your throat or in just waiting to come out of your head. Okay, and then try to see whether you can develop that into a research project. Now, how will you then move on? Suppose you have an idea and then you want to kind of create it into a project, a research-based project. Then what are the steps? So here I be very careful. I put them in numbers because I want to look at all the 9 numbers here. So which is a general procedure by which one goes about. But I'm telling you, this is only one way of looking at it, or you can say that it's my way of suggesting you to look at. There can be other ways as well, but this seems to be a very simple way as far as I'm concerned. Okay, that's why I'm presenting this to you. Okay, the first step, suppose you have an idea or you have a project in mind to develop. The first idea is you have to collect all information about it. Okay, and get everything that is available and see what others have done in that particular domain. Okay, and then what is left for you? If everything has been done in that, okay, suppose I want to make another safety pin. I mean, whatever novelty you want to make in the safety pin is not going to help you. Okay, but if you want to make a safety pin, that's going to come out, kind of, plug in some, some blood vessel or something like that. Then that is novel because it has to be biocompatible. You see, so that's what I'm trying to say. The first idea is to get information about that particular project, and then try to understand what has been done so far and what is left for you. And if you feel that, okay, that you have an innovative plan or a novel idea with which you can improve, there's a lot of scope to make a drastic improvement on the earlier work, only then you should go forward with that idea. Okay, otherwise this idea may not fetch you the kind of laurels or even award in IRIS, okay, or anywhere else. Okay, so then other thing is, once you got this particular thing, then work out a methodology. Methodology means a step-by-step procedure of solving this particular problem. Okay, so you should have a step-by-step procedure. Okay, what do I do first? What do I do second? What do I third? Okay, and then you list it down. So you'll know what are the steps involved and what are the processes through which you have to go through, so that your final product or your final idea will crystallize into the form that you want. And here I'm putting in green because I know that there are your teachers and some of the mentors are also available in this meeting, and I am putting them in green here, whatever is meant for them. You have to take their mentors help, because certain things are much beyond it. They have the experience. Okay, they have the much more experience than you, so they can tell you, okay, you are missing out this point. You are missing out this point. Why don't you take a look at this also? So they are only nudging you. They are not. They are not actually clouding your ideas. Please understand that. They are only helping you, nudging you in the right direction. And that kind of nudging is always necessary. Like you have a boat in the river. If you don't have an oar, what will happen? It will go along with the flow of the water. If you want to direct to in a particular direction, then you need a oar, right? Similarly, the mentor will work as a oar for you to direct your research towards the right direction. Okay, and then of course list down all the resources you require. For example, if you want to do a computational project, you should know what is the type of a machine you require to do the computation. Do you have the? Can you do it with the laptop alone? And what are software required for that? Or you require something like a supercomputer or something like that. It may be a huge calculation. Okay, and then the kind of resources meant for that. Can you work with MATLAB, or do you require something much? Or do you require Mathematica for that, or do you want some other resources to run this particular program that you have in mind? Or you may want to use something, put on something under an electron microscope. So then it means you have to look. You need an electron microscope, right? So these are the kind of resources that you will require, and then you check whether whatever you want, are they available within your reach, and whether they can be kind of acquired or reached by you, accessed by you. This is very important, because without that, you have a great idea. I said, sir, all I wanted was, but I need a space shuttle. Unless I have a space shuttle, my problem will not work. Then you better drop it, because you are not going to get a space shuttle for you to try your problem, right? But there are other things. There are other equivalent ones are available, which are not that very complicated. Okay, here again you require the support of your mentor. So if you have gone through all this stage and then you have come up with a project which has sustained through all these four steps, yes, now you have a solid project and the proposal and the methodology which will work. Then how do you go about doing it? How do you start working is, first the methodology. Maybe there will be all new techniques, new methodologies, new steps involved in that. So you have to familiarize yourself with those. So start with simple examples of that, try with them, and make sure that you understand that particular technique and that procedure. For example, let us say, since that you are using Excel, okay, you know all Microsoft Excel, you know. So Microsoft Excel, you know, what do you do? First of all, you want to use it for fitting some equations. The simple thing is to put a X and Y column and then fit that particular thing to a straight line, right? That will be the first step to see whether you can fit that particular data to a straight line. That is probably the easiest way, or the simplest kind of fitting procedure you can do. Okay, and then you can go for other complicated equations to which you can fit the data. Okay, that's what I mean, that try with simple ones. Then you have to collect all the inputs. What I mean by inputs is, it may be data, it may be chemicals, it may be information, it may be samples. No, it may be anything depending on what your project is. Get all of them first, because unless you have all the things in kitty in your hand, you cannot move forward. Okay, and then you have to set a timeline for each of these tasks. Okay, this has to be done in this 1 month's time. This has to be done under 20 days time. So if you don't finish in 20 days time, don't panic. You can again give it another 10, because your initial estimate was not correct. Probably you may have to push in another 10 more days, but it cannot become 6 months. Then it's dangerous, because you are running out of time. Okay, similarly, you have to kind of keep on having a timeline and keep on checking whether you are running. It's like a marathon race, and every lap or every step you have to kind of complete and particular time frame. Otherwise, you can't win the race, right? Okay, and of course, here also it is very important that you have to authenticate and repeat your results many times to be very sure. A one-time result which can never be reproduced is not going to help you. Okay, and then you'll get stuck with that. Okay, so other thing is you always should have what is called a logbook. The logbook is a nice storybook as a diary that you keep on jotting down whatever you're doing. It can be used like a storybook where you write in kind of the storyline, like, oh, I saw this, I like this, I got this idea from there. You can write anything you want, but make it very regular. Don't think that I can every week I'll go on a Sunday I'll go and fill up all the thing I did on the whole week. That will not work. Probably do it every day so that you can kind of on a chronological manner and a regular manner you can fill up your logbook, because this is very, very important when you bring your project for the IRIS National Fair. Okay, then always aim high. What I mean by that is look for an output, a product or a result that is much, that should be very, very high. Okay, and then you may not be able to achieve all the 100% of it. But what I mean by if you aimed it high enough, even 80% success of that is going to is sufficient for you to get a good project through. Okay, and then be flexible. Okay, because I don't think that I decided this methodology, I'll go only by that. It is like, don't do that kind of, we know that something will not work. You should not go on bashing your head onto on a wall which you can't cross. Okay, so you have to you have circumvent and leave the wall and go around rather than try to bang on the wall. Right? It doesn't help. So you have to always be flexible. Maybe you may have to retweak your methodology and work back and do it, and then always adapt to the situation. There should be a plan A, then there should be plan B, C. Some people say you can even go up to Z. Okay, so have the options ready with you so that, and be flexible. But but doesn't mean that first time when experiment has failed doesn't mean that you have to immediately change to another area. Try and make sure that understand that it is not, this particular process is not going to help you, and only then move on to the next one. Okay, right. And now the people who want to do experiments, right, and then conduct experiments, you are from a school, and the school may not have more than a chemistry or a physics lab for you, and within that scope only your teachers and your school can support you. But some of your experiments, your ideas may be much beyond the laboratories, the infrastructure of your school. Well, it doesn't matter. In fact, but you have to, so you can always, but the only thing is when you are, that's why I said, no, when you are planning your resources, you should know what are the equipment, the techniques you require. You should have an idea about that. Okay, otherwise, you'll get stuck in the middle. Okay, but I want you to recall this second point I'm talking about. If some of the Nobel Prizes were actually won with work which were done with minimal sophistication. I have seen the kind of setup that C.V. Raman had used. Okay, because one of his last students was my professor. Okay, I had this great honor of working with the last PhD student of C.V. Raman. Okay, so he told me the kind of equipment that C.V. Raman used. They cost you, in today's rate, it will be about 150 rupees or 200 rupees only. Everything was handmade and things like that. Okay, and in fact, he had to keep the entire room dark. That's why his lab is called the Black Hole of Calcutta. You would have heard of that. Okay, so it doesn't mean that unless you bring in so much of sophistication and great instruments in name, you will get an award. Awards are not given based on that. It's given on basis of what you have done and what is the final product you have done and what its worth is with respect to what is available. Okay, but nevertheless, if you really want some advanced techniques or sophisticated instruments for your work, many of our earlier students have done that. They have used some very sophisticated instruments. Some of them even surprised me, because those things I used only during my PhD days. But some of these students could do that, and they have done that. Okay, and these things are available. And please talk to your mentors whether these are the right techniques to use, and then where to get them. There are plenty of places available in India. India now is actually a real big temple for scientific research, because we have so many IITs, so many ISAs, NITs, NIPERs, CSR labs, ICMR labs, DIE labs, DBT labs, DST lab. I mean, in every city you'll have at least half a dozen of them nowadays. Okay, so there is no dearth of labs which contain all these sophisticated instruments. And the scientists and and the faculty members available here, most of them are willing to help a young mind. Okay, I have, some people have contacted me, I have helped, and many of my colleagues have also done so from an IIT. So this is nothing for you to be surprised about, because we also get fascinated by young minds with, bright young minds with new ideas. We always support them. So will others. Okay. Again, you have to get help of your mentors, maybe your parents and others, so that you can find which is the nearest place where you can get that particular technique or the lab that you want. Okay. But however, we understand one thing. See, those equipments are all costly and then very difficult to maintain and run. They may not even allow you to run it yourself, but they will get you the data for it. Okay. But you have to be very specific about why you require it. You should have full justification, and you also should have an understanding of that particular technique and why you require for your work. So this is a lot of homework. You have to do all that homework, probably get some tutoring also. In fact, on any instrument that you are talking about, you can Google, you will get a YouTube now. And YouTube video about any of these sophisticated instruments or technique, you will get a YouTube video. So you can always read them and then understand before you go, and then make it a proper request through a proper channel. Proper channel means you write through your headmaster or your principal or through your mentor. Then it will be received. Otherwise, most of these people get hundreds of requests and they can't cater to everything. So how will they know something is genuine and something is not? So you have to also make it in a proper way. Okay. Now, two more points which I want to touch upon before I hand over to Dr. Vijay. See, what you should keep in mind when you're writing a good synopsis, because you're all going to come up with synopsis in maybe in a month's time. So the first thing is you should have clarity of thought and language. Unless your language and your thought are clear, you are going to mess about what you're going to write. Okay, so you have to clearly put your thoughts together before you start writing it. Okay, then define your objectives. The objectives have to be very clearly defined. What is that you plan to do and where you are reached, and use precise scientific language. Okay, don't use languages which are non-scientific. Okay, so and then not very precise. It may be done, it can be done. I mean, nobody cares what can be done. What have you done? You have to write. Okay, and what you got, rather than saying that it may be done, it could have been there. I mean, so those kind of hand waving statements are never appreciated, and it only shows that you are shaky and you are not confident. That's why make sure that your language conveys your confidence that you have in your and the expertise you have in your own project. Okay, and present all available data in the proper form. It should be in the form of a table or column or a graphical form, so that it is easily kind of understood by others. Okay, and then point out the actual novelty or innovation in the project. Don't think that whatever you think as novelty cannot be pushed into us. Okay, so you should really gauge the word novelty and understand what innovation means, and you should point out what actually is a novelty here. You cannot say nobody has done, I am done it. We have seen not kind of nobody has done, I am trying this. Okay, some of them are, if you yourself read it second time, you will feel is very foolish. Okay, and then you don't have to kind of prove your point beyond a point. Suppose you got something, a good idea, a simple good idea you got. Okay, that is enough, good enough. You don't have to be extremely novel or extremely out of the world for it to be a winning projects for you. Okay, and then of course point out what is actually done and what is remaining to be done clearly. Many times we don't understand in the synopsis what has been done, so whether it's being done or already done. So these things have to be very crisply mentioned in the space given. There is also additional space available for you. When you see that that form that you get for filling up, you will understand what I am talking about. Okay, and then please remember one thing. This particular synopsis that you are putting up is meant for you so that your project is picked up without much of interaction with you by just reading and understanding that. Will your very for you whether read and understand what you have done by reading your project with a synopsis? Try it with a couple of your friends and see whether they understand what you have done by showing your synopsis to them. Then probably it's ready for you to send and upload. Okay, and please remember that this is actually IRIS projects are actually they are in two levels. One is that you actually come to this IRIS fair. We select something like maybe it's around 100 projects overall out of around 1,000 or so that we get. Okay, and out of these about 10 to 15 they go to ISF USA, and between this national fair and the ISF fair you will be mentored by one or more than one of us. We will help you improve your idea. So even some ideas which are kind of 80% done can also be further tutored by us. So don't worry about that particular part. Do your best. Okay. And then of course the last part I have to talk about this before that I can wind up. It is about the ethical issues, because ethical issues are very important in anything you do. And without you bringing in a little bit of discipline in the way you think and bit of sincerity and truthfulness in the what you do, you will never able to sell yourself. Okay, we all know that. Okay, so one of the things that people often don't do that is that whenever they have a partner, okay, you may have a two students may be doing a project that is permitted here. Okay, give due credit to her or him. Okay, so that is very important, because and make sure that person also works. That fellow cannot be a dumb fellow standing behind you. Make sure that the work is divided. Two people means should be double the work you are able, should be able to do, not half the work. Okay, divided by two. Okay, okay. And now the other thing is that understand the word plagiarism very clearly. Okay, please Google this, find out, because whatever I explained to you, you will not be able to reach and understand that. If you do not know the meaning of this, please understand the full and complete meaning of plagiarism. What amounts to plagiarism, and you should avoid it at all cost. Not only in this project, but in your entire career as a person also. Never try to copy others without proper acknowledgement of that. Okay, of the one person who has already done that. Okay, and don't claim it is your novelty when it actually has been done by somebody else. Okay, that's in simple language what plagiarism means. Okay, and if you think that somebody did in some part of in the Nordic country somewhere in Sweden, nobody will know, you'll be sadly mistaken. This time in this kind of current world, everyone can find out, and if it is found out at a very later stage, it will be very disappointing for you and and be very bad for all of us. Okay, and so that's why please make sure no plagiarism is involved anywhere. Okay, acknowledge every source of information, whether it's from another human being or from another media, like from Wikipedia, from other sources, some books or whatever it is. Okay, never present any data or result without verification. A single time data obtained cannot be presented unless it's verified at least once or twice. Okay, and strictly follow ethical guidelines and never do anything that may bring disgrace to you, your school, or our nation. Okay, this is what I want to tell you. And finally, we look forward to your synopsis. Stay healthy and safe, and thank you for your attention.
Thank you so much, Srinivas, sir.
I think I'm done,
Thank you. Thank you so much, sir. We will now have, that was really, really informative. And we will now have Dr. Vijay Kumar continue with the presentation on physics and astronomy.
Yeah, I am done.
Thank you. Thank you so much, sir. There will be questions later, sir. So, yeah, we will, once Vijay Kumar, sir, finishes his presentation. Thank you, Srinivasan, sir.
Thank you. Can you see my slides?
Yes, sir. Yes, sir.
Okay.
Yes.
Good. Okay. So I will talk about scientific discovery and innovation, especially in physics. So Professor Srinivasan already talked about the various important points that need to be taken care while writing the project. That is, he talked about how to find a project idea in the category of physics and astronomy, how to develop a research-based project in this area, then how and where to conduct experiments, what to keep in mind while writing a good synopsis, and last point is ethical issues that must be keep in mind while doing science projects. So all these points are very important and you must understand while writing your project. So basically my talk is very general. Basically it is a kind of motivational. So first I will start with the definition of the science. So I picked a few definitions, so you can find out in the Google as well. So science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predicts about the universe. So basically we can test the information and we can explain based on the test and predict about the future. Science is knowledge attained through study or practice. So we can get the knowledge through study or practice, or knowledge covering general truth of the operation of general laws, especially as obtained and tested through scientific method and concerned with the physical world. Okay, so we can test the results with the help of the scientific methods. Science is the pursuit and application of knowledge and understanding of the natural and social world following a systematic methodology. So basically, it is a systematic process. So we have to follow the systematic methodology in order to get the evidence. The important point is the observation, identification, description, experimental investigation, and theoretical explanation of phenomena, which leads to new advances in science and technology. So these are very important points. While performing experiment, what we do, we observe the thing, then identify, then we describe them in a better way, then we do experimental investigation on that particular thing, and then there must be some theoretical explanations for the results we obtain, and in order to have advances in science and technology. So this is the scale of the universe mapped to the branches of science and hierarchy of the science. So you can choose or you can opt any one of the topic or any one of the branch of the science as per your interest. So you can start towards the higher diameter, or you can start towards the lower diameter. That is, so you know there is a different branches, like you can work on sociology, psychology, then of course astronomy, geoscience. Then in life sciences we have functional biology, cellular biology. Then in physical sciences we have chemistry, physics. In physics, like quantum mechanics, classical, relativistic, and other branches of science. Then of course you have the formal sciences, then you can take the problem in mathematics, like also you can take some logical problem. So this is the skill. So you can choose the topic as per your interest, and accordingly you can work on the project. And already Professor Srinivasan already explained very nicely the various important points that need to be keep in mind while writing your project or synopsis. So next is what is discovery? So discovery is known as the act of detecting something. So whenever you detect something that already pre-exists and has been around over a long period of time. So if something is already existing and we detect, that is known as the discovery. Discovery means to find out, to figure out, or even to acknowledge something that has been in nature for a good number of years. Discovery could also include forces or other objects that are not solid in nature, such as gravity, force, atmosphere, gases, etc. So all these are related to the, you can say, the discovery. So discovery is generally not intentional. So we do not do such type of thing intentionally, and can be stumbled upon by accidents such as gravity. So mostly it is not our intentions to discover something, but sometimes they are discovered by accidentally or all of a sudden. So some of the important discovery, like the penicillin, this is I have mentioned here only the few, so but they are very, very important. Of course they change the scenario of the world. The discovery of the oxygen, the DNA, and the electricity, so they change the world like anything. So the act or process of introducing new ideas, device, or methods is known as innovation. So basically innovation is the process and outcome of creating something which is also of value. If you create something, that is called innovation. Innovation involves the whole process from opportunity, identification, ideations, or invention. So basically in innovations, there is an involvement of the idea, invention to development, prototype. You can make the prototype if you have an idea. So you can, of course, produce your idea, then marketing and sales, while entrepreneurship only needs to involve commercialization. So if you have a good idea, then you can commercialize that. You can go for the patent. But of course, the important point is the novelty. If you have a novel idea, then of course you can do a lot of things. And of course that idea must have some value also. So now the difference between innovation and invention. So this is again very, very important, especially for the students. The invention is referred to finding of a new concept, theory, element, phenomena, etc. So when you find out a new concept or a theory or element or phenomena that refers to the invention. Whereas in case of innovation, as I said, creating a something, creating a product or process or techniques based on the existing concepts, theory or elements. So based on the existing knowledge, we can create a product or process or techniques. That is we call that a innovation, to innovate something. In its purest sense, invention can be defined as the creation of a product or introduction of a process for the first time. So when you create something for the first time, that is invention. Means you invented something. Innovation, on the other hand, occurs if someone improves on or makes a significant contributions to an existing product. So if you modify something to a larger extent, that is, we call that a innovation. So you must understand the meaning of innovation and invention. Some of the innovations that changed the history. So I will show you some of the innovations like the compass. So this, of course, this changed the history. Samuel Morse, who invented the electromagnetic telegraph, as well as 2 separate devices for sending and receiving messages. So nowadays we can talk to anyone all over the world. So this discovery was really, you can say that it changed the history or it changed the world. Of course, the currency also. Then Henry Ford, the motion pictures. Of course, you know the Steve Jobs, Bill Gates, and Steve Wozniak. So they also made a lot of innovations, and of course, they changed the world. Then Wright brothers, America takes flights. So all these innovations, they changed the history. Then some of the Indian scientists who changed the world. So now I will show you the couple of images. Of course, you might know him, Sir Chandrasekhar Venkat Ramana. He is the Indian first Nobel laureate in the field of physics, and the world famous scientist was C.V. Raman. He got the Nobel Prize in the year of 1930 for his discovery, the Raman effect. So, you know, the Raman effect was very important, and of course, you know what is this. So, Raman effect, basically, it is the change in the wavelength of light that occurs when a light beam is deflected by a molecule. When a beam of light traverses a dust-free transparent sample of a chemical compound, a small fraction of the light emerges in direction other than that of the incident. Most of this scattered light of unchanged wavelength, however, a small part of wavelength different from that of the incident light, its presence is as a result of the Raman effect. Homi Jehangir Baba. So, of course, you know about the Homi Jehangir Bhabha. So, Homi Bhabha is the father of the modern India's atomic program. In the year 1937, he had intensively researched on the subject cosmic radiations and found the particle called mesons. He became world famous with that discovery. Kudos to his exemplary vision, India achieved self-reliance within the shortest possible time and developed its nuclear technology. So the nuclear technology in India is only due to Homi Jehangir Baba. So during the year 1963, India established its first nuclear reactor. This is because of Baba's leadership abilities. Within 2 years, India had surprised the world with the establishment of plutonium plant. Venkat Raman Radhakrishnan. So Venkat Raman Radhakrishnan was a space scientist and member of the Royal Swedish Academy of Sciences. Radhakrishnan's contributions to science in general and in astronomy in particular was exceptional. His observation and theoretical insights helped the community in unraveling many mysteries surrounding pulsars, interstellar clouds, black sea structures, and various other celestial bodies. So Venkat Raman Radhakrishnan's discovers various aspects of the space science. So the famous scientist JBS Haldane remarked upon him, given good conditions, anybody could turn out acceptable birth. So this is, these two lines are very, very important. Of course, Given good conditions, anybody could turn out acceptable work. But the mark of a true scientist is that he can create the requisite condition and make great discovery. So, like in if you do not have like too much facilities, then of course you can also do the great thing. The scientific career of Professor Radhakrishnan, of course, exemplifies the spirit of this statement. So next is of course the S. Chandrasekhara. So S. Chandrasekhara was born on October 1910 in Lahore, British India. He was awarded the 1983 Nobel Prize for Physics for his mathematical theory of black holes. So the Chandrasekhara limit is named after him. He was nephew of C.V. Raman. Chandrasekhara became a United States citizen in 1953. His most celebrated work concerns the radius of energy from stars, particularly white dwarf stars, which are the dying fragments of stars. So next, of course, you might know him, Satyendranath Bose. So S.N. Bose was an Indian physicist specializing in quantum mechanics. He is, of course, most remembered for his role played in the class of particle bosons. So who might study like classical and quantum mechanics, they knows about the bosons, which were named after him by Paul Dirac to commemorate his work in the field. So the discovery or the most of the work was done by, you can say, S.N. Bose on bosons. In 1937, Rabindranath Tagore dedicated his only book on science, Vishwa Parichay, to S.N. Bose. The government of India awarded him India's second highest civilian award, the Padma Vibhushan, in the year 1954. Meghnad Shah. He is one of the great astronomical scientists of India. His ionization formula is considered as the milestone achievement in the domain of astrophysics. It helps the astronomers to calculate the temperature of the various celestial bodies like sun, planet, and stars. So he has given a formula with the help of that we can find out the various parameters like temperature of the celestial body, temperature of the celestial bodies like sun, planet, and stars. He also invented an instrument to measure the weight and pressure of solar rays. But did you know he was also the chief architect of river planning in India? He prepared the original plan for the Damodar Valley project. So this is all about the Meghnad Shah. Of course, the next is the Jagdish Chandra Bose. So basically, he was a physicist, but he worked on the like the bio. So plants respond to stimulus. So like when you change like the pressure, temperature, there is a change in the something, that is we can say that when you change the stimulus, the plant respond. Like they weep, they laugh, they become angry. This was proved scientifically by one of the greatest scientists of modern India, J.C. Bose, a scientist in physics, but did many inventions in the domain of botany. So basically he was a physicist, but he did a lot of work in botany or biology. He had for the first time in the modern science removed the barriers between physical science and natural science. So nowadays we say that we are working on the interdisciplinary. Okay, so earlier there was different branches of the science, but now we can say that the interdisciplinary. So we can work on physics, chemistry, bio, mathematics, like all that, or combination of all. So today we are living in a world of wireless communication. The technology was first invented by J.C. Bose. So the concept of wireless communication was given by J.C. Bose. He had demonstrated it in the world forums and seminars, but Marconi had patented the technology first and became the owner of its application. The credit of this greatest achievement should go to J.C. Bose, not to Marconi. So it was, of course, the statement. Next is Vikram Sarabhai. Of course, you know him very well. So he was considered as the father of India space program. Vikram Sarabhai was born on 12th August 1919 in the city of Ahmedabad in Gujarat. he was instrumental in the setting up of the Indian Space Research Organizations, that is ISRO, when he successfully convinced the Indian government of the importance of the space program. So the space program is only due to Bikram Sarabhai. He was awarded the Padma Bhushan in 1966 and the Padma Vibhushan after his death in 1972. Some of the, now I will explain some of the previous project that went for ISAF, and this is the project of Antara Bhattacharya. So the title of the project was Single versus Multiple Planetary System, Insights from Analysis of Explanatory. So basically, the main idea was, and the motivation behind this project was, many explanatory systems have been discovered recently within potentially habitable zones around the stars. However, a lot of explanatory data has still not been fully analyzed. So in her project, basically, she collected the data from the NASA Explanet archives, and Explanet orbit database were used to study various aspects of the planetary system formation. In particularly, she examined the distribution of the planet, like the mass, the radius, the orbital period, the stellar temperature, and the metallicity, statistically in single as well as the multiple planetary systems. The cumulative frequency distribution of these parameters were then plotted and compared, and the two samples tests were performed to check if the distribution are statistically different or not. So now you can see that she plotted a different graph with planet mass, planet radius, orbital period, stellar metallicity. So she has done a lot of experiments, and ultimately she got very good results, and of course the committee members agreed that of course this project have some potential to go for ISAF. The second, the second project was determining the space debris and the collision prediction using quest theory. This is by the Aswath Suryanarayan. So this is the abstract of the proposal. That is on 10th February 2009, a satellite's Iridium 33 and a space debris Cosmos 2251 unprecedentedly collide, producing more than 2000 cataloged space debris. So collision like this and the one that routinely occur in the Earth orbit led to an increase in the density of the space debris, which is a threat to the stability of the orbit environment. So basically, he studied about how to avoid the collision between the different debris. So beyond the critical density, the Kessler syndrome, a cascading collision phenomena would occur. This can be prevented by the collision prediction and debris removal. However, the current collision prediction models are not sufficiently accurate. As a novel approach, basically he applied the chaos theory to predict the space debris collision. So this is close approaches and orbits with better accuracy. The chaos theory has its application in stock markets and weather predictions. So we can use this chaos theory in stock markets as well as for the prediction of the weathers, and bring some order from the chaos. So his research leverages the tools of chaos theory. Basically, he used the short-term Lyapunov exponent, that is LCE and LT, which are applied to evaluate the final error of the simulated trajectory. So basically, he has done kind of simulation with the help of the chaos theory. So now you can get an idea how already Professor Srinivasan talked about the important points, that how you can write the project, how you can write the synopsis, how you can go further, how you can take the help of the mentors, and of course where you can do your research work. So already all these things are already explained by Professor Srinivasan ji in a very nice manners. And with this, Actually, I have taken only the 2 examples of the earlier project, and already you know that the different categories in the physics already explained by the Professor Srinivasan: atomic, molecular and optical physics, astronomy and cosmology, biological physics, condensed matters and materials, mechanics, nuclear and particle physics, theoretical, computational, quantum physics. So, as pointed by the Professor Srinivasan, that there is a lot of scope to have a project in physics subcategories. Like you can see, we have a lot of problems, and we have a lot of course, categories in this physics and astronomy. So you can choose as per your interest and as per your knowledge, and of course you can write a good synopsis. Thank you so much.
Thank you so much, Dr. Vijay Kumar. Thank you. Students, I'm sure that today you have received a lot of inputs from both our subject category experts. And before we take questions, we will quickly go through the IRIS video, which is compiled by whatever students over the past years have been saying. We've compiled that together and created a video for you. So please take a look at that now, and then we'll go for questions.
Are you ready for the ride of your life? Well, it all begins right here. Your first step is picking a category you can enter by yourself or with a partner. If you are in 5th to 8th standard, you will be in junior category. If you are in 9th to 12th, you are in senior category and have a chance of making it all the way to ISEF. Now that you know which category you are in, it is time to find out which subject your project comes under.
At IRIS, you have a variety of 21 subject categories to choose from, ensuring that your project has a category that fits. The categories include animal sciences, behavioral and social sciences, biochemistry, biomedical and health sciences, biomedical engineering, cellular and molecular biology, chemistry, computational biology and bioinformatics, earth and environmental sciences, embedded systems, energy, sustainable materials and design, engineering mechanics, environmental engineering, material sciences, mathematics, microbiology, physics and astronomy, plant sciences, robotics and intelligent machines, system software, and transitional medical sciences.
A display shows the public and the judges what you have done. You're looking to attract and inform visitors about your project. So make it easy for people to access your results by creating a clear, attractive and concise display. The focus should be the work. Take a look at this reference.
Your title should be simple and must accurately represent your research.
Take photographs or videos of important parts or phases of your experiment to use in your display.
Prepare a miniature of your model in case your prototype is too large to be carried along.
Make sure your display is logically presented and easy to read.
Use neat, colorful headings, charts, and graphs to present your project. Pay special attention to labeling.
Be sure to adhere to the size limitations and safety rules when preparing your display.
The IRIS journey begins with registration on the website www.irisnationalfair.org with submission of online synopsis and supporting documents. These entries are prejudged by the IRIS Scientific Review Committee and shortlisted projects are sent an email inviting them to participate in the IRIS National Science Fair. Winners of the IRIS National Science Fair qualify for an intensive series of mentoring camps and get the opportunity to represent India at platforms such as the Regeneron International Science and Engineering Fair in the United States of America. ICEF is the world's largest pre-college STEM competition. Over 265 Indian students have won over 160 awards at this competition, competing with over 6 million high school students from all over the world each year. Not only are you getting a chance to make your nation proud, but if you're lucky, you could join the 31 Indian students who have had minor planets named after them.
So guys, please don't miss this opportunity.
It's your turn now.
If you're innovative and you really want to bring about a change in the world, I think IRIS is the right place for you.
You enjoy science and math and computer science and so on. So I mean, it gives you a platform to show what you've done, and you have a chance to go to ICF too.
If science actually kindles your curiosity and you're really passionate about it, IRIS provides you the largest platform in India to show your talent.
Applying to IRIS, not only get to have a great experience, you meet great people and great mentors at that. They're not judges, they're not judging you, they're mentoring you, they're teaching you. They make you learn new things.
In the end, it's not about winning or losing, it's about experience, and IRIS National Fair guarantees great experience.
Don't tell people what your dreams are. Show what your dreams are through IRIS.
It's once in a lifetime experience.
It's your turn.
It's your turn. It's your turn.
It's your turn.
It's your turn.
It's your turn.
It's your turn.
Right. Do we have any questions? While the questions are being asked, we would also like to put up a brief presentation on, the subject categories and the way in which one can actually apply for IRIS. We'll keep that presentation going, but we'll take your questions at the same time. So Dr. Srinivasan and Dr. Vijay Kumar, we'll take the questions now.
So there's a question that has come to us in the chat. The question is, are the statistical observations based on the formulas of regression? Because all the observations were similar to sigmoid function used in the logistic regression. This is a question for Vijay, sir.
Can you repeat the question, please?
Are the statistical observations based on the formulas of regression? Because all the observations were similar to the sigmoid function used in logistic regression.
Yeah, of course, we have to, we have to see the statistical variations. So if we are plotting something like if we have a straight line and if we find out the slope, then of course we have to see whether value of r square is very close to 1 or if it is very less than 1. So that should be there. So we have to see the value of the you can say that the regression coefficient. Or statistical, of course, the error should be minimum, as pointed by Srinivasan sir already during his talk, that the error should be very less.
There is a question asking what type of physics projects do you expect from junior category? Is any new method or improved method of measurement of physical constraints acceptable in principle?
Certainly. Certainly. There's no doubt about that. The only thing is be sure that it is totally new, because many times we are under the illusion that many things that you're doing are new. So first find out, as I told you, the first step is to find out if somebody has already done it and what is the amount of information available on that particular what do you call that instrument or that idea, and then what is that your contribution is. If it is considerable, then yes, you have a very good chance of even getting an award.
Yeah, of course, there must be a spark in the project. If there is a spark in the project, of course that will go. If it is a only just a extended work, then it will not go. It should have some innovativeness. Novelty should be there.
There is Mr. Vijay Mathur who has his hand raised from the participants. I will now unmute your microphone and you may ask our speakers your question.
Good afternoon, participants. I just wanted to share my experience of the 2002 ISF fair in Louisville, Kentucky, where it is a very proud moment when the Indian team got 2 minor planets named after them, Mother White and Finger White. And I want you all to participate in that. I'm now retired, but still trying to take part and be a mentor to the local students in Odisha. My question now was to Dr. Srinivasan. Sir, in my time, we were encouraged to ask the children to have a open-ended question where we were encouraged to use the word maybe. Maybe this event will happen if we put in these parameters. And then to test and then come up with this we did, and this is what we got. So in your initial discussion today, you had mentioned about being very careful about the maybe element. I want you to clarify on that, sir.
Yeah. I agree to you, what you are asking. Yeah, see, the maybe actually is a very funny word. You rightly said that. See, for example, if there are actually your data, for example, you have done an experiment and you have got a data, and then actually you're trying to compare it with some certain models. And then it happens to be that, it kind of fits into 2 of them, but more likely into 1 of them, okay? More precisely than the second one, okay? But you always have a problem that you have a limited amount of data. So you cannot concisely say that it is the prior one. So in this case, you can always say it's most likely, or maybe I rather use the most likely, the other one, rather than saying maybe it is that. You understand what I'm trying to say? This is what I mean by maybe and the most likely. I rather use the word most likely than maybe.
Yeah, the element of 3 sigma, 5 sigma is changing so rapidly that we really have to become more precise, even at school level, sir.
Right. That's see, I believe in that. Using the word most likely gives that spells out the confidence you have in your testing as well as in the model you have used. And maybe it doesn't give you that much of confidence in a person, right? When you hear it, that's what I was trying to say. I mean, that's the only difference. It's a very subtle difference between the 2 of the words. That's it.
So, thank you, sir.
Yeah, welcome. Welcome.
So there's a question from Miss Lily. She asks, astronomy labs are not available in schools. How can students choose topics? How will they do investigations? Please suggest a platform or software that will help with astronomy related topics.
Shall I take that question?
Yeah, please.
Yeah, right. See, this is actually the kind of the 2 problems that Dr. Vijay Kumar presented. I will rather almost call them as astronomy projects, in the sense that they talk about the celestial bodies only. They are later on that. So they actually, what is happening is that NASA, for example, there are a lot of missions of NASA, Kepler mission and so many and so forth. A lot of data are available there. And many of this data have not been analyzed, for example. And one of that, in fact, the exoplanetary work that Antara did is like that. It is a data available, and she just only went and asked for it, got it, and analyzed that. So such kind of you have to look for those data, and they can. Astronomy doesn't mean that you look through a telescope. I'm sorry, if you're thinking that looking through an optical telescope and looking up into the sky, that is not the astronomy I'm talking about. We go much beyond that. Okay, radio astronomy, a lot of data is available in radio astronomy. Like if you look at a particular sector arc of this particular horizon, you can always get a lot of such data available. In a routine matter, people collect data, and this data sometimes give you wonderful information. That's one way to look at. The other thing is that see, this is what I'm telling you. If you are hell bent on doing only on astronomy, then you better have some kind of an idea on what is it you want to do on that. You see, you cannot take a fancy. For example, I like the word ASTRO. Anything that starts with ASTRO, I'll do on astronomy. It doesn't work like that. And later, see, I have seen people who started with something else, ended up somewhere else. Okay, I know, you remember that gentleman who talked to you about, Saral. He is a person who had no biology in his 11th and 12th class. And he made, I still remember, it was about 10 years back, almost 7-8 years back, Saralka project. It was on, bone meal. It was an absolutely biology project done by a student who did not have biology as his 11th and 12th. Okay, just to give you an example of what I want to tell you. Are you getting my idea? What I'm trying to tell you? Please, there are a lot of information and data available. You have to look for them. That's all. Thank you.
Participants, if there are any other questions, please type it in the chat or use the raise hand icon.
Yeah, don't be afraid. Yeah, ask questions. See, I always tell my students, the stupidest question is the one which remains in your head. The one which comes out is never stupid. Okay? Please ask questions.
There's someone called Yashraj who's asking me a question privately. Yashraj, maybe you can ask the question directly to our experts, please.
Come on, Yash, come on.
So Yashraj's question is actually, it says, when we are outside from the house in an open field, how can we save from thundering? Can you tell some precautions?
I think Srinivasan sir is the right person to answer this.
Sure.
I think because of the lightning strikes, the question, the recent lightning strikes which have happened, I think that is why this question has come out, and it's a it's a very genuinely curious one. Yeah. So,
actually, what is lightning? Actually, in physics, we call it as simply a dielectric breakdown. Okay, this actually the electric charge that is generated there actually breaks the dielectric of the air and then hits the ground. So it finds the easiest path of motion and reaches the ground. So where does it reach the ground? When it reaches the ground, it doesn't want to reach to the lowest part of the ground. So it always try to hit the highest kind of the point available. So unfortunately, if you are 7 foot tall and you are walking on an open field, okay, when there is a lightning very close by, it may hit you. If there's a tree nearby which is taller than you, it may hit it. Okay, so that's the basic science behind lightning. Okay, so the best thing that you do, in fact, the ideal thing that you can have is you create what is called Faraday cage. Like you have a metallic shield, or you get into a car. The car is a metal, for example. So, and then if the charge falls on it, the charges will be on the surface. That's what electrodynamics tells you. And then the person sitting inside will not be affected by it. Okay, so that's why people say never go and stand under the tree, because it may get the lightning bolt and you may also get electrocuted along with that. But sitting in an enclosed metal surface with you insulated away inside that is probably the most safest way. You got my answer?
Thank you, sir.
Yeah.
Any other questions, participants?
In the chat, there is someone asking, are theoretical works accepted?
Yes. I already told you, your proof can be experimental or theoretical of your idea. So
yeah,
it can be yeah.
Yes,
sorry.
Please, sir.
Go ahead.
No, please, sir.
Yeah. So for example, if you're testing a mathematical hypothesis, I mean, it can be done in two ways. Either you can do it in an analytical and theoretical way, you can do it in a computational way, or an experimental way, or a combination of all three. Okay. For example, certain equations cannot be solved analytically. That time you have to use computational methodology, right? So, or the best thing is to actually, everyone would like to do an experiment and prove it, but many times this may not be possible. So that time, the next best thing possible is actually is the theoretical way of doing it. So it's a perfectly accepted methodology. Thank you.
There's another question which has come. Why does the universe work the way it does? Why are the laws of physics mostly the same in our universe? Okay. Sir, would you like to take this question? I don't know. The participant is asking, why does the universe work the way it does? Why are the laws of physics mostly the same in our universe? I mean, okay.
See, this is a very fundamental question you're asking. See, the mere fact that you call it a physical law is because it's working. Okay, and I'm not sure about the universe. See, there are actually frames of references from where it can change. So you have to be very careful when you use these words. What works in Earth may not work in other places. It may be slightly different. Okay, and then there are there are events which are relativistic and non-relativistic. So your statement is also not entirely correct. There may be changes depending upon whether it can be relativistic effect or it can be another frame of reference. Then the same law may be slightly affecting in a slightly different way.
Thank you, sir. I guess a few of our participants, are asking very, very basic questions. But yes,
no problem.
Every question is welcome. I know.
Every
Thank you so much.
So actually he must, read about the theory of relativity. Then definitely he will get the answer.
And they wouldn't have studied relativity at this stage. That's why. That's the problem.
That is the issue.
We have a participant who has their hand raised. Tavish Kaul, I will now unmute your microphone and you can ask the speakers your question.
Okay. Good evening, sir. Sir, my question is how the priest know the person who can detect the future of through the astrology. How the priest can see the future of a person through astrology.
Okay. See, now you are moving from science to meta science. See what actually astrology. What actually it talks about is that it says that has to be again verified. Okay. So as a scientific mind, you have to decide whether that particular hypothesis is correct or not. Okay. They always say there is a connect between the celestial bodies, their movements. Okay, especially 9 planets, and your life. Okay, so they say they make your chart called Kundali, right? And then they depending upon the time and the date of birth, they know which particular planet or star is in the ascent, and then that's how they fix what is called the main house or the lagna. Okay, and then they also with respect to that they have to fit all the different planets in your 12 houses. Okay, and then they actually look at how these planets move around, because they have a particular motion, right, about the sun. So they use that particular scientific aspect and try to say that how it is going to influence the person. So this actually is called a science. That's why it's called astrology. Okay, so it's up to you whether you can believe it or not. One way is in some cases people have found that, well, something happened yesterday and I could correlate it with that particular predictions. But tomorrow, how are you going to compare that? You have to leave the tomorrow to find out that. Okay, that is where the proof has a problem. Okay, while the past can be kind of connected and can be tested, the future is very difficult to test. And if you are an experimentalist and you are a scientist, you would like to have the proof before you conclude whether it is a real science or not. Okay, so now you decide what you want to do about that. Okay.
Sir?
Yeah.
My another question is, how can we define that the whether I'm relating to psychology behavior of science, how the people have, whether they are having some type of disease, how can you define?
So I will intervene here. We will be having psychology, behavioral science is another subject category, and I think we'll store this question for the next one. I'm not having this question answered over here. I'm not permitting that just now. Please wait for the webinar on behavioral science to ask this question.
Yeah, this is good idea because it is related to behavioral science.
Yeah.
Also.
Yeah.
So I think they can answer in a better way.
Mm-hmm. Yes, I can see that there are some participants replying to others. Thank you very much. That's really, really nice because we can see your involvement. Thank you, Aryaman Bhutani. You're responding to Ayushman's question. Ayushman's question was, if we have not gone beyond the Milky Way galaxy, how can we identify the universe? And in response, Aryaman Bhutani states, we have not even passed the solar system. In fact, we can detect the various celestial bodies using telescopes which collect light from various regions in the spectrum. These give us the information of whatever we can observe in the universe. The limit we call observable universe. Thank you so much for that.
Yeah, is correct.
There is also another question which has been typed out. This is by someone called Arkin. How long will Voyager 1 be in working as it has already reached the heliopause, which is a large success for humanity?
Do you want a truthful answer from me? I do not know. No, you'll be surprised. See, I do not know because we have to see how long its energy that is powering its motors will function. Whether solar panels or the other things that it has. I do not know. I don't remember that. What exactly is the lifetime of that particular mission? I'm sorry.
There's a very interesting question from Preeti Kumari. She says, there are certain videos showing the sounds of planets on YouTube. My question is, when the space is entirely vacuum, it has no medium, how can they record such sounds?
Sorry, actually, I have not seen those videos, so I can't comment. What I have not seen, I can't comment about. I'm sorry.
Okay.
That is actually, some of the videos are fake, like the moon's conspiracy. If they have seen the video. So they have, I think that is appointed by USA and other countries. They said that it is not possible, that there is no vacuum. So why the flag is, waving like that? So they can refer to such type of video and they can get the answer, I think. Because these are, of course, a very silly question.
Thank you so much for the answer, sir. There's another question from Yash Raj. He's in class 9 and he is requesting that we tell him what is the cause of buoyancy force. What is
you
the
should
cause
read your physics. See, you should read your physics. This is very simple and you should know that. If you read your textbook, you'll understand that. It's a reaction.
Yes.
Right? So you should know that.
We have 3 participants in waiting who have their hands raised. Ma'am, are we taking questions?
Yes, I think we can take these 3 questions and then we can close for the day.
Anshu Khanna, I will now unmute your microphone. You may ask our esteemed speakers your question.
So I can see there is a question in the chat that from Pritam Das. Sir, I am a MSc student in physics. I want to pursue my passion toward astrophysics and want to do research in this area. What should I do after completing my master? To get a PhD admission, of course, you have to clear the NET or the GATE exam. Then, of course, you will get an admission. Like in Delhi University, they have like kind of astrophysics facility, and like you can go to IIT or some other institute. But you need to clear the NET exam. Without this, you cannot get the admission in PhD.
GATE will also do for IITs.
Yeah, of course. GATE and NET, of course.
Yeah.
Since Anshu Khanna is not being able to connect, we'll go to the next participant who has their hand raised. Dinesh Kumar Sharma, I will now unmute your microphone.
Hello.
Yes, please proceed.
Hello, namaskar. Good evening
Yes,
to all of
please.
you. As far as my information, in the field of magnetic nanoparticles, there is no much more work has been done. Can it be taken as project, sir?
Could you please repeat the question?
Yeah, I got the question. See, the question is, a lot of work has been done in nanoparticles. Okay, sir, you are a teacher or a student?
I am teacher, sir.
Fine. Then you will understand. I can little more elaborate. See, what is happening is that the most unique thing that happens in a magnetic nanoparticle is that when the size goes down, okay, to nanometric scale, then what happens is that the size of the particle will be almost a size or smaller than a domain size, magnetic domain size. So it will become what is called a single domain particle. Okay, a single domain particle behaves in a very different way. So there's some new phenomena are available there called super paramagnetism, which is not seen in materials which are in the bulk. Okay, so this particular phenomenon and this kind of materials, for example, iron oxide, have been well studied. But there are many other materials which are still people are looking at. Okay, that has not been done. And other thing is, what are the applications these materials have? They are used for basically for, you can always, add up what you call a tag, a drug molecule, and then you can use what is called the directed drug delivery. Or you can use it as a MRI contrast agent. All these applications are possible. So people are now trying these applications. So only in these applications part, now actually the particular that area is now standing. Okay, so the phenomenon is known. Materials which exhibit have been studied a lot, but many of these applications are not be fully exploited to come to the commercial level. And there is also something called hyperthermal treatment of cancer that also can be used with these kind of materials. Okay, so such kind of applications one can always explore for a particular material that you have developed, which can be very good for this one of these applications. That is always possible.
Okay. Sir. Thank you.
I hope you followed what I was telling you, because I mean, since you are a teacher, I went a little more technical. The other students may not understand this. Yeah.
Thank you, sir. Thank you.
Yeah, welcome. Yeah.
Ma'am, may I now ask the question?
Yes, please go ahead.
So good evening. I'm Anshu Khanna. I'm a teacher. I'm working in Amity International School. So every year we always register 3-4 projects from our school for IRIS. But actually what is required there, I want to know. Is technology always required for a project?
Can I answer that question? Can I answer the question?
Sure, sir.
Yes,
Please.
sir. Sure.
See, this is there are two things you have to understand. See, the problem that most projects that we see happen to be, I told you, run of the mill kind of a thing. Like people look up a previous year's project and do a little bit of tweaking of that and bring it. So that doesn't really seem to impress anybody. So that is one of the major problem we have been facing. For example, we have phases. For example, there was a set of years when you have all this thing made on wind tunnel based, energy based, piezoelectric based. So that kind of it's a kind of a well-known thing, well-known idea, and the novelty factor was completely missing. Yes, the student has done a lot of work, and they have come up with many things. I'm not denying the fact. Okay, but we look for novelty. So that's where the whole the problem lies. Okay. The second thing is that yes, technology is not actually important, but but technology gives you an advantage. I was giving an example when I said, for example, we talk about this deep learning and other ideas. Now they are being applied to things like image analysis and things like that. And as a researcher also, if you look at IIT University itself, there are people who are working in these kind of areas. Okay, so these are all. If you look in, I will bring a project with that kind of applying a new technology to an old problem and getting new results. That's something different. But if the same old projects are brought back in with like little bit modifications, they don't get through. So that seems to be the, I don't remember what projects you are referring to, but this seems to be the general problem that we are facing as screening people at the level of the synopsis level. Have I answered your question, ma'am? Hello? Was I clear?
Hello?
Yes.
Sir, last year...
Was it okay? Yeah.
Sir, am I audible?
Yeah.
The thing is that last year we registered a project.
Sorry, I'm not able to hear.
I think the participant has muted. The participant has...
I think her microphone is, she's not unmuted.
Ma'am, it is okay?
Yes, now you're audible. Yeah.
Sir, I'm just asking that last year our students, they registered a project that was a piezoelectric charger to be used in phone. So is it possible that we put the piezo cells under the keypad, and whenever we are texting or this thing, that energy utilized for charging the phone, at least not full, but for emergency?
See, ma'am, this is actually a very tricky question you're asking. See, whenever you're giving a proposal, piezoelectric crystals, their efficiency, you know how much it is? It's very, very low.
Yes.
So the conversion efficiency is so, unless I start banging every time I give a texting, along with my, I'll be texting, I also start banging it on the table, I'll not be able to generate sufficient energy. So what I'm trying to say is that the viability of how much energy you are generating, how much power you are generating, whether that will be sustained that particular machine or not is what we should look at. If we can justify that, yes, then there is definitely a good project.
Okay.
So, ma'am, first and foremost, I would like to add over here. I don't think it's a very good idea to be discussing a project because there are other people on this platform.
Okay.
So you're going to be losing advantage over there. The other thing is,
we registered it last time, and it didn't work.
Ma'am,
so
ma'am, your point is well taken. See, we are teachers. Okay, we are all teachers. I'm a teacher like you. Only that I teach in IIT, you are teaching in the school. That's the only difference. We are all teachers. Okay, and what we do is absolutely transparent. Okay, we love the children. At the same time, we have to be fair in what we call is right and what is wrong, which is allowed and not allowed. So anytime you ask any question for what you have done, we are ready to answer you. So don't worry about it. I can answer you. Yeah.
Okay. Thank you, sir.
My clarification here is that if it's a new project that you're going to do or you're going to add to, then don't discuss it here. But if it's an old project, please go ahead. Please discuss it. No worries on that. Okay. So
Okay, ma'am.
yeah.
Thank you. Okay.
Yeah.
Thank you, sir.
Welcome.
There are 3 more participants that have their hand raised. Are we taking questions?
Sure, why not? The only thing is, see, this has turned out to be more of a physics roundup rather than the project roundup. So I'll be happy if you guys ask me questions related to the project idea you have in mind rather than general physics questions. I'm sure you have much equally educated or better than me teachers are available around you, your school and otherwise. Okay, so please put your questions which are relevant to the projects and IRIS. Okay.
So there's one question which is coming up repeatedly on the chat is, why is the universe expanding?
So someone already answered this question, and of course this is, you know, again a silly question. They can find the answer in I think +2 book. Otherwise, if sir want to add something, so please, sir.
I think it's already been explained. Somebody
Yeah,
answered it on the chat, so that's great. We are happy that this interaction is also happening, that you can actually have questions answered on the chat. That's great.
Basically, these are very, you know, basic questions. So they are not related to IRIS project, or as sir said, you know, the question should be related to the project. That will be good. They are, you know, very basic question. They can find.
Otherwise, we can have another session on general science. There's no problem.
Yeah.
So, any more hands raised? Anyone else who wants to ask a question? We'll take 2 more questions and then we'll close the session.
So there's Shalini S who has her hand raised. I will now unmute you, Shalini, and you may ask the speakers your question. Shalini, go ahead, please.
Hello? Hello?
Yes, Shalini, please go ahead.
My question is, what is beyond universe?
I do not know. That is my answer.
There's a Rohan Pandey who has his hand raised. Rohan, if you have a question related to a project that you would like to submit in IRIS or any queries regards IRIS, then I am going to unmute you. Otherwise, kindly lower your hand. That goes for the rest of the participants who have their hand raised as well. Please ask IRIS related questions to the speakers for any guidance that you would require for the project that you would be registering for IRIS or any queries thereafter. Biswadeep Chakrabarti, I will now unmute your microphone and you may ask the speakers your question. Biswadeep?
Would you be able to hear me?
Yes,
good evening,
you're
sir.
audible.
Yeah. So actually, I'm a teacher. I'm working in Delhi Public School, and previously I worked in Hemshila Model School, Durgapur, and 2-3 times we have also sent a project in IRIS and being selected also. Now, being a long time in some time means with the high school students in the R&D department, the problem, I think it's a problem with me only, means limitations. Actually, being in the +2 curriculum, we could not able to expand ourselves a lot. And many students are coming with many different ideas. Sometimes we don't have the answers for all those things. So if would we able to get some support from you people? Actually, as we don't have answers of all those, and then after sitting and completely new things to see, because when the students are coming, sometimes they are coming with many different topics, not only physics. They are compiled the physics and astronomy and then biology, physics. So many things are coming like that, sir. And my limitation, actually, this is my limitation what I'm telling, that I could not able to go beyond many things over there, because in being in long time in curriculum, I just bounded with all these things. So
yeah,
if
I didn't get your name.
Bishwadeep Chakravarti, sir.
Yeah, Mr. Chakravarti, I understand. See, this is true for all. Yeah. Like, see, do you think that I can confidently answer a question if a high energy physicist asks me a question about Dirac equation in certain conditions? I cannot.
Yeah. Yes.
I also say I do not know. So I fully agree with you. I fully agree with you. We are all learning every day. Okay, and we are wiser every day over yesterday, right? This is always the case.
Yeah, definitely.
And then, see, what I want to say is there are many science portals available. Okay, and there are many discussion sessions available where you can get all these answers. You can put up. Otherwise, you can contact any one of us.
Yeah.
Yeah.
That only I'm asking, sir.
But
Whether
again,
we
I'm
can
telling you.
contact, we can give
See
your
again.
mail ID
Again,
to
I
our
want
student that
see.
they can able to contact you. Yeah.
Yes.
Yeah.
See, for example, you might have heard of Professor H.C. Verma.
Yes, definitely, sir.
See, S.C. Verma, actually, he has a portal for that. He is, anytime you can wake him at 12 o'clock in the night, he'll answer you happily. What I'm trying to say is that there are dedicated people who are actually, who love, giving knowledge. And a lot of people are available like that. The only thing is, please ask them not to stay with a doubt. Let them get clarified. There are many ways by which they can get it clarified. And if we can help, we'll be very happy to do so. You're most welcome.
Thanks a lot. Thank you. Thanks a lot, sir.
Thank you so much. Thank you so much, sir. Dr. Srinivas, thank you so much, Dr. Vijay Kumar, for taking these questions and for being our expert speakers for today. For all the participants who are with us, thank you so much for joining us. Thank you, teachers. Thank you, students. Thank you, experts, again. And the recording of this webinar will be available on the IRIS National Fair website and also on the IRIS YouTube channel. So do follow us. You've got the slide over here, shows you exactly how you can follow us. And if there's any question that you have, you can either contact the esteemed speakers. Their email IDs are given in their presentation today, or you can write your question in to us at contact@irisnationalfair.org. Thank you so much, everyone. Have a great evening. Thank you once again, Dr. Srinivasan. And thank you once again, Dr. Vijay Kumar.
Thank you so much,
Yes, stay healthy and stay safe. Yeah.
Yes, thank you so much, sir. Thank you. Bye. Bye-bye.
Bye.